be covering a little chapter 4 practice. This first part here deals simply with protons, neutrons, and electrons, how to calculate them, how to write these things, how to write elements in shorthand so you can convey a lot of information without writing out a whole bunch of information. So here we go. When we're looking at the periodic table, there's a couple things that we just need to pay attention to. Okay, one thing is how to interpret, how to read certain things that we see on the periodic table. Okay, for each element that has a very similar format to this, we know obviously that that's the element name there. Okay, our symbol is right above that. Now remember, if we're making a one-letter symbol or all symbols, first letter is capitalized. If we have a two-letter symbol, something like CO, the first letter is capitalized, second one is lowercase. So this here is cobalt. Alright, our number up top, okay, this number right here, the 6, that is our atomic number. Okay, now what does our atomic number tells us? Our atomic number tells us the number of protons or electrons. Okay, that's what the atomic number tells us. And our bottom number here happens to be known as the atomic mass. You may see this written also as atomic weight, same thing. Now the atomic mass is equal to the number of protons plus the number of neutrons. Okay, so that's very simple, a very quick way to see quick breakdown of what we see here in a periodic table designation. Okay, so let's go ahead and talk about how we can write a couple of these in shorthand. Alright, we're going to take a moment to write a couple of these in shorthand here. So let's look at shorthand. Okay, so way to convey a lot of information without taking up that much space, really. Okay, so looking at one way to write shorthand is this right here. Okay, the 12 on top actually represents our atomic mass. Okay, where the 6 on bottom represents the atomic number. I'll just represent with that a pound there. Okay, so we know that's how we do that. Now, carbon, okay, carbon 12, if I just simply write carbon 12, that 12 at the end is the atomic, okay, that is the atomic mass. Alright, so if we were to write something like this for gold, for instance, okay, gold. Well, gold's symbol is AU. Okay, and if we look at our periodic table here, gold is right down here. It's 197 and 79. 197 and 79. So we've got 197 and then 79. Alright, that's our atomic number right there, and that's our atomic mass. Now, if we were to write gold this way here, we'd write gold, and then simply 197 to represent the atomic mass. Pretty easy, pretty straightforward. Okay, so now we've got 3 different elements here. How many protons, neutrons, and electrons are in the following atoms? So let's see if we can calculate this. Let's start off with helium. Okay, helium. We need to look at helium. It might help just to draw our little thing, our shorthand notation here to help us out so we don't have to keep on looking back and forth from the periodic table. So let's zoom over to where those elements are located. Alright, helium is right up here. It's got an atomic number of 2 and a mass number of 4. We keep that mass number. We don't write the whole thing there when we're calculating protons, neutrons, electrons. We round it to the nearest whole number. So let's go back. We have 2 and 4. So we have 4 up top because that's the mass, and then 2 because that's the atomic number. So protons, neutrons, and electrons. How many do we have of each? Okay, so protons. Alright, let's remember. Protons we get from the atomic number. So our atomic number is 2. We also get electrons from there, so we have 2 electrons. Now how do we find the number of neutrons? Okay, we get the number of neutrons from calculating basically atomic mass minus atomic number, and that gives us neutrons. So 4 minus 2 equals 2. So we have 2 protons, 2 neutrons, and 2 electrons in helium. Okay, so let's go ahead and move on to the next one, neon. Okay, neon, let's look for its mass number. Alright, neon has 10 and 20. Okay, that 20.18 just rounds down to 20. Not enough there to round it. Okay, so 20 and 10. Okay, 10 is its atomic number, 20 is its atomic mass. So protons, neutrons, and electrons. Alright, so protons we found from the atomic number, so that's 10 and 10 also for electrons. Now neutrons, we take the 20 minus the 10, and that gives us 10 neutrons. Pretty simple, pretty straightforward, hopefully for you guys. Alright, so let's do our last one here, bromine. Okay, bromine. Need to look at the periodic table again. Bromine has 35 and 80 as its numbers, because 79.9, the 9 rounds up the other 9. Okay, so that's 35 and 80. Or in this case, if we're writing in shorthand, 80 and 35. So protons, neutrons, and electrons. Alright, protons we find from the atomic number, so we have 35 protons. We have 35 electrons, and neutrons, okay, 80 minus 35. Do we need a calculator? Well, we might. Well, let's might as well do that to show it there. So 80 minus 35 equals 45. So we've got 45 neutrons. Any element on the periodic table we can do this for? Pretty simple, pretty straightforward. Alright, so let's do a couple more problems here before we end this section. How many neutrons are in the following atoms? So we don't even have to look at the periodic table now. We've got all our information given to us already. So let's get rid of that real quick. Okay, so oxygen, 16 minus 8. That gives us 8 neutrons in oxygen. Alright, we've got Ag here, which is silver. 108 minus 47. Okay, maybe we need a calculator for that, so let's go ahead and do that. 108, whoops, 108 minus 47. And that gives us 61. Whoops, where did that come from? That's weird. Alright, so 61 neutrons in silver. Okay, and then lead, 207 minus 82. 207 minus 82. So 207 minus 82 equals 125. So we have 125 neutrons in lead, Pb. Alright, and then for our last part here, we're going to express the following items in shorthand form. So niobium is 93. Okay, so we know that that 93 there tells us the atomic mass. We know that that 56 there tells us the atomic mass. We need to find the atomic number for each of these. So niobium, let's look at the periodic table here. Let's find it. It's in the middle. It's in the transition metals. Okay, niobium has an atomic number of 41. So 41. But where did I write that? Oh, I wrote that in the wrong place there. My bad. Okay, so we want 93, 41, and then niobium is in B. Okay, and that's how we'd simply write it in shorthand. Now, iron symbol is Fe. We put the 56. The 56 goes on top. What is the atomic number of iron? Iron has an atomic number of 26. And so that's where we stop there. Alright, so that's just our first part, how to write things in shorthand. This way it lets us to write down a lot more information without actually taking up a lot of space on our paper. And how to find protons, neutrons, electrons. If you need any help on these, extra help on these, just let me know. Alright, thank you.